In this lesson we're going to look at the industrial extraction of iron from iron ore. So here we've got a sample of iron ore, and this is composed mainly of a substance called hematite, which is also iron 3 oxide with the formula Fe2O3. But since this is a mineral and basically it's a type of rock, there are also silicates mixed in with the iron ore. So we have silicates here. And to extract the iron from the iron ore, we're going to use a process called reduction. And this is going to take place inside this blast furnace. So to carry out the reduction of iron ore, we're going to add a mixture of the iron ore itself and coke into the furnace. And the temperature of the furnace around about here is going to rise to a temperature of around about 1500 degrees Celsius. Now it's called a blast furnace because hot air is being injected into the furnace at this point, and the hot air helps to increase the temperature still further. So around about here at the bottom of the furnace, the temperature is going to be over 1600 degrees Celsius, at which point iron is in its molten or liquid state. So let's look at the process of reduction. So as I said earlier, we're mixing iron ore with coke, and coke is a pure form of coal or carbon. So what will happen is, first of all, the hot air injected into the furnace here will burn the coke. That's to say the carbon in the coke will react with oxygen to produce carbon dioxide. So the first step is the coke burns. That means carbon reacts with oxygen to produce carbon dioxide, and then the carbon dioxide reacts in turn again with unburnt coke or carbon to produce carbon monoxide. Now, carbon monoxide is not really happy as carbon monoxide, it wants to be carbon dioxide. That's to say, it has a hunger for this extra oxygen atom. So we can class this as a reducing agent. So a reducing agent is something which wants to grab hold of oxygen in this context. Right, so it's the reducing agent in the process. We need to balance the equation. First of all, let's do that. We've got one carbon that side and two carbons this side, two oxygens, so we need to put a 2 there. So this is going to be used to reduce the iron 3 oxide in the furnace. So let's write out the word equation for that. Carbon monoxide plus iron 3 oxide. So the carbon monoxide grabs hold of the oxygen from the iron 3 oxide. So the iron 3 oxide is reduced to iron, and that leaves carbon dioxide. So the symbol equation becomes CO plus Fe2O3 gives us Fe plus CO2. Okay, so we've got to balance this equation now. These reduction equations are often a little bit tricky now. So this is what I'm going to do. First of all, I'm going to count the oxygens on each side. We've got 4 oxygens on this side and we've got 2 on this side. So what I want on this side is I want 2 oxygens, and to do that I'm going to put a third here. All right, there we go. So we have 3 oxygens here, but multiplied by a third gives me 1 oxygen. So I've got 1 oxygen there and 1 oxygen there. That's 2 oxygens on that side and 2 oxygens on this side. We've got 1 carbon, we've got 1 carbon, but on this side we've got 2/3 of an iron atom. That's to say we've got 2 irons there divided by 3. So I'm going to put a 2/3 there. So actually everything is balanced there. But the problem is you can't have a third of an iron oxide molecule and you can't have 2/3 of an iron atom. So we've got to get rid of this denominator, and we're going to do that by multiplying the whole lot, both left and right, by 3. Okay, so that gives us 3 carbon monoxides. 3 times 1/3 is 1, which is Fe2O3. We've got rid of that third there. We multiply 2/3 by 3, that gives us 2, right? 2 iron there. and 3 carbon dioxides. Oops. Okay, and now our equation is balanced. Okay, so we've extracted iron from its oxide. The temperature down here is above 1600 degrees Celsius, so iron, which has a melting point of 1538 degrees Celsius, will be in its liquid state here, and we are able to tap the iron off. So the iron will come out in its liquid state. So the last thing we have to look at is the problem of how we deal with these silicates which are present in the iron ore. We remember that iron ore really is a type of rock. It's a rock that is very, very rich in the mineral hematite. That's iron 3 oxide. But there are also other substances present, particularly silicates. For example, sand is a type of silicate. So we can write the formula for these silicates is SiO2. And the problem with these is that they have a very high melting point. So at the temperature at which iron melts, the silicates are still in the solid state. So there's a danger that you're going to get bits of sand mixed in with the molten iron as it's tapped off from the furnace. So these silicates have to be removed. And to do this, we're going to add limestone to the furnace. Okay, so we're adding limestone to the mixture of coke and iron ore. And let's have a look at what happens next. What we're doing is we're removing these impurities. So we're removing silicate impurities. Now limestone is made from calcium carbonate, whose formula is CaCO3. And when this calcium carbonate is added to the furnace, it will decompose under the intense heat into calcium oxide and carbon dioxide. Calcium oxide is also known as quicklime or just lime. Now this is quite reactive, and this will react with the silicates to form calcium silicate. And at these temperatures, calcium silicate is in the liquid state, but it has a lower density than that of liquid iron, so it will sit on top of the liquid iron at the bottom of the furnace and can be tapped out of the furnace as something called molten slag. Okay, so all of the sand and the impurities are removed. Okay, so all of the sand and impurities in the molten iron are removed in the form of molten slag. That's calcium silicate. And this cooled slag is then used in the construction business, for example, for road building, and also, for example, for making fertilizers.